Hi, my name is Fernando Serto. I'm a director of security technology and strategy here at Akamai. In my 5.5 years at Akamai, I've witnessed a huge growth in particular types of attacks, and one of them being credential stuffing. So I'm here today to share some of the insights into this problem and how widespread the problem actually is. I'll start with actually defining what credential stuffing is, right? So in our industry, in the security industry, that is, we tend to talk about terms that people are not really used to, and sometimes it's really difficult for the security business to actually talk to the rest of the IT organization or the rest of the business in order to explain what the risk is. So whenever we talk about credential stuffing, we're actually talking about all of these, lots and lots of data breaches that we've been hearing about for the last few years on the internet. Passwords, usernames and passwords being stolen, email addresses and passwords being stolen from breaches like Yahoo and LinkedIn. And what we mean by credential stuffing is really that the strategy is pretty straightforward, right? So attackers are taking these huge data dumps of usernames and passwords, and they're actually trying to reuse those against pretty much any login page on any website that they get their hands off. The reason why this problem is so widespread is that because us as humans, we tend to reuse the same combinations of usernames and passwords. So everyone who has a personal email address, they will use that email for every website that they have an account on, like their favorite retailer, their favorite media company, the streaming service, whatever that may be. And obviously, passwords that are easy to remember. So just to show how big the problem is, Akamai has been doing analysis for the last 2 years and a bit on how bad credential abuse or credential stuffing attacks are against our customers. And in the period of almost 2 years, we managed to observe about 85 billion credential abuse attacks against our customer base. So that is a pretty big number. Whenever we're talking about credential stuffing, we need to reference one key component of these attacks, right, or these types of attacks, which is really bots, right? Bots, or short for robots, are really something that we use this term because of the automation of a process that bots provide us. Now, whenever we're talking about bots, we can be talking about good bots and bad bots, and the internet's full of them, right? Both use cases. So I highlighted a few of the use cases here for, whenever we're talking about valid processes or good bots, we're talking about chatbots or search engine optimization crawlers, such as Google or Bing, and also data aggregation. So these are, things that we use to automate a lot of these processes, and they're used for good, right? So to improve the experience of users of a particular application or website, and obviously to improve mind share and things like that, and market share for organizations that own those applications. Now, whenever we're talking about malicious bots, we're talking about really credential stuffing or someone trying to brute force passwords. Retail inventory sniping, which is really the ability to buy goods as soon as they're launched. So if you're really keen on a particular luxury fashion item, you can pretty much hire a bot to buy that item as soon as it becomes available. So you don't need to actually wait in line or wait on the online line in order to buy those as well. And a huge spike in crypto mining that we've seen over the years as well. Now, the challenges that a lot of organizations face is really the fact that detecting bots is becoming more and more difficult, right? There's things like increased risk, things that are, that the business hasn't really caught up with, or they can't really keep up with how evolving the threat landscape is. Looking into assets that the business doesn't even know that are exposed, so assets that are unprotected, so applications or websites that the business doesn't have any security controls around, and obviously the potential impact on applications and IT assets going up. Then we talk about high complexity, right? So a lot of these bots, they can operate with a high degree of complexity. And So understanding the attack surface is really hard sometimes. Like understanding what every type of application, every content management system that's out there, and being able to mitigate against those proactively becomes really complex for any IT organization to protect themselves. And obviously, the lack of visibility that a lot of people will have as well as one of the big challenges for the IT organization. And now, when we talk about agility, so IT is really not moving as fast as the business wants them to. So they're always responding to fires, and they're never really being strategic. So all these three items, they really add up to, and they are the reason why it becomes really hard to detect a lot of bot attacks. Now, just to illustrate what bots, where they operate. So if you think about bots and humans accessing applications at the same time, you have your users on the right, and you have your applications being hosted within your enterprise, in your data center, in your cloud data center, whatever that may be. And then we have bots, right? As I mentioned before, we have good bots and bad bots. So if you think of a single bot, someone running a script against a particular application, trying to collect, stats. You're looking into, various tag managers, looking into various analytics systems. All of these are good bots, right? And they can be really widespread, right? So hundreds of thousands of, if not millions of these bots around. Now, the problem is that as distributed as good bots are, if we add a malicious person into the mix, or an attacker, now that attacker can also start commissioning bots and botnets, which is a combination of bots, to actually start generating malicious attacks. So all of a sudden, you're not only looking for good traffic from your legitimate users, from your analytics services, from any other marketing tools that you have that may be classed as the good bots, you also have a bunch of malicious activity as well against your applications. So these will be used typically to launch distributed denial of service attacks, which Akamai also sees a lot of. They're going to be used to launch credential stuffing attacks, which is the main topic of today's discussion, and also to control malware or host command and control systems all over the internet as well. Now, I mentioned this before, but it's very important to remember that malicious bots can vary in complexity as well. And so to highlight that, I brought up three different use cases here where you can see that, you can understand how difficult sometimes it can be to mitigate against these types of attacks. So in this first case, we're talking about an international retailer that sells goods all over the globe in pretty much every country you can think of. And they thrive on online business, right? So they have a lot of customers that are buying directly from them and not from other places such as Amazon and places like that. So in this particular instance, when we got engaged with this customer, we actually started to look into what the traffic actually was hitting their applications, and it was pretty quickly for us to realize that a lot of traffic. A lot of unique requests were hitting the login pages for the website. So where customers actually punch in the usernames and passwords to check the gift cards, or look into previous purchases, or update their addresses or credit card information, whatever that may be. We had to redact a lot of the information here because these are live customers, so we have to be careful with how we share this information. But one of the things that we wanted to highlight here is that although this very small snippet of traffic that I pulled out of the reports is actually from customers coming from China, but all of the IP addresses that were flagged in this particular snippet of traffic, they actually all classed as good IPs. So there's legitimate users behind these IP addresses as well. So that causes a problem for a lot of people who are still stuck in the mindset of protecting against attacks using blocking IP address techniques, right? Or using firewalls, for example, right, to block that. So I highlighted as well on the bottom of this slide a couple of things that we look into. So our platform is capable of looking into how the behavior of this traffic looks like, and then we're able to classify each one of these requests into potential botnets, right, or what we call botnet ID. So we look into a lot of characteristics into these bots, and we're able to group them into particular botnets, so we can run better reports and understand where and who they're attacking. And these will be important in a second when I come to the next few slides. But in this particular case, the reason why we started blocking these particular IP addresses was because there was no human behavior associated with these requests, right? So we have a bunch of rules, a bunch of triggers in our platform, and whenever we don't see a lot of those being present, the combination of those will actually be what we call a trigger, and we have the ability to have actions based on each of these triggers. Now, one really interesting thing was that when the customer engaged us, they didn't really know that they were already under attack. And once we started to share this data with the customer and actually started to share the behavior of a lot of this traffic, we helped them do some analysis, and they believed that they actually had more than 10,000 accounts that were breached into in this particular campaign. This other use case here, which is the forgot password case, I thought it was really interesting to highlight as well, because every now and then we start talking to customers, and whenever we bring up credential stuffing, they typically say, well, credential stuffing is only valid when we're talking about usernames and passwords that came from another breach, right? So I'll use LinkedIn as an example, which is from a few years ago, but a combination of email addresses and passwords. And a lot of times, customers will come to us and say, well, I don't use usernames or email addresses as IDs. I actually have member IDs, which are unique. So those member IDs wouldn't really be present in any of these data breaches that we had over the years. But then they forget that they have a potential backdoor here where the forgot password feature on their login page may actually be exposing them. In this particular case, with a real customer here in Asia Pacific as well, we actually looked into their forgot password pages, and we realized that if you try to recover your password using an invalid member ID, you get a message saying member ID was not found in our system. Now, if you use a real valid member ID, you get a message that just says if your member ID was found, you will receive an email. So from an attacker's perspective, they already know that if they send a randomized number and they're trying to validate valid or confirm valid member IDs for this particular application, they know what to expect from a response perspective. And this is exactly what we saw. So in the space of just a few hours, we saw almost 80,000 requests against this particular forgot password page, and all of them coming from a single IP address. And as I mentioned before, a lot of the malicious bots that we see, they vary a lot in complexity. In this particular case, it was a super simple bot. And we actually believe that this was just a single machine running a very simple script that was just validating, sending a number, a string of numbers, and actually looking into the response and seeing if it was a valid member ID or not. Now, if you remember as well, when I mentioned about one of the use cases for malicious bots is actually the ability to brute force passwords, or even just check random usernames against various passwords. So this is exactly where an attacker would look into what are the valid member IDs that we already have, and now we can try a massive combination of passwords and just use the member IDs as usernames, and passwords that come from all the other data breaches as potential passwords for this. And now the last case that I wanted to talk about is a large financial institution where, when we're talking about unique IDs or unique usernames, Financial institutions are really well known for that, right? So they typically don't want you to use your email address for logins anyway. And this is sort of a security by obscurity kind of thing. So if you don't know what the client numbers are or the member IDs or whatever they may be, it becomes a little bit more difficult for you to actually be able to validate what a real account is. So then we have more aggressive types of attacks against financial institutions. In this particular one, I had to hide a lot of information as well, because you would be able to identify who the customer is. But this is all the traffic that we're seeing against the login API, and looking into excluding everything that matches traffic coming from the mobile app, right? So we were just looking into straight traffic going into the APIs. This is something that happens very, very commonly as well, where we see the same customer being attacked by multiple botnets at the same time. So looking into these two particular botnets here, we started to do some analysis on what they look like. So this is a screenshot of a tool that we have within Akamai that we call Bot Intelligence Console. And whenever we have these botnet IDs, we actually have the ability to compare attack traffic from between one customer and the rest of the industry. And this is exactly what we're doing here. So we're comparing traffic against this one financial institution versus every other customer we have in financial services, as you can see on the top right of this screenshot. So something that we want to highlight here as well is that, a lot of times you don't need a very sophisticated botnet to be able to be successful in an attack campaign, right? So the sophistication on this botnet is not really that great, right? So we're looking into, it supports cookies. So, the reason why we were blocking traffic was because we were seeing cookie replays a lot and a few other triggers, obviously. But then we start to look into how many customers or what percentage of Akamai's customers are being targeted by this particular botnet. And you can see the spikes on the bottom part of this chart, which is really financial services traffic. So you can see that almost half of every financial services organization that is behind Akamai today is actually seeing malicious activity from the same botnet. One thing that is worth highlighting as well, or another thing, is the pervasiveness of this botnet. So when somebody scores a 10, it's the highest score that we have on our platform. And I want to highlight this when we compare to the next botnet. But on this particular day, which was only about a month ago, so on the 27th of March, we actually saw a very targeted attack against this one financial institution, where almost all the traffic from this botnet across all of our customers, across all of our platform, was actually almost 100% targeted against this one financial institution. So that goes to show that they were being targeted, and it wasn't just an opportunistic type of attack. I mentioned before about how difficult it is for you to start putting controls based on IP addresses, geography, or anything like that. Just to show sort of the scale of this botnet, which is almost dedicated to financial services. When you look into almost 40,000 IP addresses, or an even scarier number is the number of networks or AS numbers that have bots that belong to this botnet is running within their networks, right? So 3,500 AS numbers or networks is a pretty big number. And the sophistication from the botnet, and if you look into the resources, there's a lot of activity on password resets. There's a lot of things on account creation, so fake accounts being created in financial institutions. And that goes to show that the operators of these botnets, they're actually being very creative from a capability perspective. Now, when we start comparing that to the smaller botnet that we saw attacking this same customer, we can see that both the sophistication score and the pervasiveness score, that they're significantly lower. But we see that when we look into the overall number of customers in Akamai that are being targeted, it's not really a lot. And this particular customer was ranking number 17 across all of our financial services customers. And looking into sort of not that many requests, and that goes to show to us that it's a much smaller botnet as well. So if you look into 1,100 IP addresses, it's not, obviously it's a fraction of what the other one was with 40,000 IP addresses, but also even at 340 AS numbers, it becomes really hard for anyone to do any sort of geo-blocking, right? Or looking into, potentially hotspots for malicious activities, certain countries that you just don't want any traffic from, and so forth and so on, right? So now if you go back to this particular slide, when we were talking about the malicious traffic using pretty much the same paths as legitimate users and trying to mimic legitimate users' behaviors, what Akamai has built over the years is really a platform that inspects traffic. It's highly distributed and inspects traffic across the globe, and we're able to apply rules where a combination of a web application firewall with our bot and fraud detection, our heuristics. So in other words, pretty much testing for verification if a particular user or request is actually coming from a human or coming from a bot. And obviously our secure operations center monitoring and response as well, to be able to provide customers a lot of confidence into our ability to mitigate such attacks. So I'll leave you with a few recommended next steps here. So Forrester has done the bot management wave in the beginning of this year in Q1 2020. So you can get the link to download that. It's a free report. You can look into learning more about Akamai's approach to bot management. There's a lot of reports and resources on that as well. And if you don't find your answers in either of those, please shoot me an email. My contact details are there, fserto@akamai.com, and I'm happy to answer any questions you may have. And with that, thank you very much for your time today.